Good morning, students. This is video number 13, part 2, chapter 3, energy. Now let us continue with the next topic. In the last video, we have finished with the types of energy. Now in this topic, we shall start with the next topic, that is interconversion of energy. The topic is interconversion of energy. Now interconversion of energy is also known as transformation of energy. Means the conversion of states that conversion of one form of energy into another form, that is known as transformation of energy or interconversion of energy. So in order to understand this topic, this is a rigid support and a pendulum is hanged on it like this. This is a pendulum, means this is a metallic bob and it is suspended with the help of string or thread. Now students, if you will displace this bob, it will start oscillating, means it will start vibrating to and fro. It will start vibrating like this. So this type of motion is known as oscillation motion. So when you will displace it from its mean position, it is displaced to the left, so it will move like this. First it will move like this and move up to the higher amplitude, and this is known as extreme position. This position of the bob is known as extreme position. Then again come back to the mean position. Let me write here, this is the mean position. Again moves upward, extreme position. This is the extreme position. It will move like this and then come back. So mean to extreme, this is known as one vibration. Mean to extreme, then extreme to mean, two vibration, then mean to extreme, then from extreme to mean, this is 4 vibration. In other words, you can say that 4 vibration makes one oscillation. 4 vibration make one oscillation. Now students, you have seen that how the motion of the pendulum takes place. What our topic is interconversion of energy, that how the energy changes. Now when this bob taken from mean position to extreme position, some work is done on it. So due to this, some potential energy was stored on it, and this potential energy made it to move to the normal position. Means when this bob will move to the higher position, it will possess potential energy, and then again it come back. Again it come back. So in other words, you can say that potential energy of the bob was converted into kinetic energy. So as we know that potential energy is the energy due to the position of the body, and the kinetic energy is the energy due to the motion of the body. When the body is moving like this to and fro, it possesses kinetic energy. So at the highest point, extreme position, the bob possesses potential energy, and here at the highest point, for a moment it will come to rest and then again come back from extreme to mean. So highest point, the energy is potential energy. When it moves back, its potential energy changes into kinetic energy. So this process goes on. So this activity clearly shows that potential energy and kinetic energy are interconvertible. Now you can take another case of bow and arrow. This is another example. Bow and arrow. When the bow is stretched, the stretched bow possessed elastic potential energy or potential energy, and when the arrow is shot, the stored potential energy of the bow is converted into kinetic energy. So there is a interconversion of energy, potential energy into kinetic energy. Now let us move to the next topic. Now so many in your book, you must go through it. Interconversion of energy by taking example of daily life. So you have to learn it for the first term exams. So what type of energy is change is there in microwave? So you can say that it is electrical to thermal. So just go through all. So many examples are given. Just go through all and try to learn it. So let us move to the next topic, that is law of conservation of energy. Law of conservation of energy. Now this law states that energy can neither be created. Energy can neither be created or nor be destroyed. What can be transformed from one form to another form. This is what is the law of conservation of energy. Once again, it states that energy can neither be created nor be destroyed. What can be transformed from one form to another form. For example, you can take one example, like we can take in a case of electric bulb. Let 10 joule of electrical energy is used to light it. So total energy is 10 joule. Now when the bulb is in use, some of this electrical energy is lost in the form of heat, and the rest is used as a light energy. So we can say that electrical energy that is 10 joule, this is equal to light energy plus heat energy, means 9 joule of the total electrical energy is used as a light energy, and 1 joule is the loss of electrical energy in the form of heat. So just see that left hand side that is equal to right hand side. So what is the law? Energy can neither be created nor be destroyed, but can be transformed from one form to another form. So this is 10 joule is equal to 9 joule plus 1 joule. This is one of the example of this law. Now let us move to the next topic, that is roller coaster. Now students, you must have seen the roller coaster in the somewhere in Ludhiana. If you have gone for picnic or enjoying the holidays, you might have seen this roller coaster. Now this roller coaster moves up and down. Means the track is set, and around that this roller coaster moves up and down like this. Now roller coasters are of many types, but every roller coaster is based upon this principle, law of conservation of energy. Means energy can neither be created nor be destroyed, what can be transformed from one form to another form. When the roller coaster is at the height, so it possessed potential energy, and when it is moving down, it possesses both the energy, potential as well as kinetic energy. But when it reaches to the ground, it only possesses kinetic, then again move to the higher track. So its kinetic energy slowly increases. So as far as this diagram is given, so from the ground the roller coaster is at the position A. So at the position A, when this roller coaster is in rest, so it just possesses potential energy only, and when it starts moving down, so it possesses both the energy, potential as well as kinetic energy. When it reaches at B, means above the ground, it possesses kinetic as well as potential energy. But in this case, the potential energy is less because due to height. So then again it moves upward. So when it will move from B to C, its kinetic energy decreases and potential energy increases because the height is increases. And when it reaches at the point C, for a moment it possesses potential energy maximum and kinetic energy is 0. Then again it starts moving downward like this only. So there is a change in the potential as well as the kinetic energy. So this is the working of the roller coasters. So one flow graph is given, potential energy at position A, then while moving kinetic energy, low position B kinetic energy, then high position potential energy, low position D kinetic, then potential energy, as I explained to you. Now just move to the hydro power plant. Now the topic is hydro. Hydro means water. Hydro power plant. Now the electricity which we are getting in our household circuit, that is being coming from the hydro power plants only. So means dams, like dams. So what has been done? First of all, the water is stored in the reservoir. The water is stored in the reservoir, then it is allowed to fall through the pipes with the high speeds. Means when you can go through it, when the water is stored in the reservoir, the stored water possesses potential energy. And when this water is allowed to flow through the pipes, so it possesses kinetic energy. And when this flowing water strikes to the turbine, so turbine starts rotating. Means potential and kinetic energy changes into mechanical energy. Mechanical energy means both potential as well as kinetic energy. And when this turbine rotates, the armature of the generator rotates, and due to which the electricity is generated. Means this generator is made up of one armature. That armature rotates. When it rotates, the current is produced. So this is the working of hydro power plants. Now students, with this your chapter is finished. Shortcut is given, some important terms are given. You must go through it and try to learn all this thing. Even I have explained everything to you. Now straightway move to the back exercise, which is given at page number 56. Work out. Now work out page 56. First of all, we shall do A. Take the best choice. Tick. Now, first, 1 joule, the answer is 1 Newton meter. Then the second, mechanical energy consists of both potential as well as kinetic energy. So C is the correct answer. Now the third is a stone at height has potential energy. due to position, because we know now what is the definition of potential energy. Due to position, energy possessed by the body due to its position. So at height, the energy possessed by the stone is potential energy. Now when fireworks are lighted in a celebration, then chemical energy changes to heat, sound, light, all of these. Now the next is electrical energy changes to heat energy. Oven, that is also run with the electricity. Geyser, that is also run with the electricity. Toaster, the functioning of toaster is also done with the electricity. So the answer is all of these. So once again you can go through it. The answer of first is B, second is C, third is B, fourth is D, and fifth is D. Now the next question is mark true or false. Ability to do work is called energy. This is true. You can write it true. I'm just writing here B, true. So you can go through. 6 is true. Ability to do work is energy. 7, international unit of energy is joule. That is true. Then kinetic energy is due to position of the object. That is false. Then energy can be destroyed. That is false. Energy can be transformed from one form to another. That is true. So you can go through it. This is now you can go through it. This is now fill in the blanks. C part. Fill in the blanks. The first one is potential energy is due to position of a body. Once again, potential energy is due to position of a body. Then pendulum of a wall clock has mechanical energy. Mechanical energy means both potential as well as kinetic energy. Now 13 is when work is done on an object, its energy increases. Means the potential energy is converted into kinetic energy. Means there is a gain in the energy. Now next is define energy. This we have already done in the video. So you can go through that. 14, 15, 16, 17, 18. So definition I have already told you in the last video. Now move to the next, transformation of energy. E1. I'm just writing here. E, match the following. Match the following. 19 question. A4, B3, C2, D1. Just check it. Match the following. A4, B3, C2, D1. Once again. Light to chemical. It is a process in the plants. Photosynthesis. Electrical to light. That is lamp. Chemical to electrical, dry cell. Electrical to mechanical. That is electrical motor. Now students, next is answer in detail. Answer in detail. F. Define and explain the term energy. Express energy in proper units. So you can open your book. First of all, this is 20. You can start from here. This is the answer of 20th question. Answer of, first of all, you have to just write energy is defined as the capacity of doing work. It is the ability to do work. Any definition you can write. Now you have to explain the term. You can give this example only. You can give any example from electricity bill is paid as per the reading recorded by electrical meter. So in this case, electrical appliances consume electrical energy and electrical energy meter record it. You just give one examples. So after this, the question is express energy in proper units. So the units of energy, you can start from there. Again, I'm just writing, this is answer 20. Third part. Simply, the SI unit of energy is joule. The SI unit of energy is joule. No need to write work, as our question is totally related with the energy. So you just write the SI unit of energy is joule, and then you can write this also. The another unit of energy is calorie and kilocalorie. Another unit of energy is calorie and kilocalorie. So 1 kilocalorie is equal to 1000 calorie and 1 calorie is equal to 4.2 joule. Then another unit of energy, that is 1 electron volt. This is 1.6 10 raised power minus 19 joule. So what you have to write in proper units? First of all, you write the SI unit of energy is joule. Another unit of energy is calorie and kilocalorie. Then write this relation. 1 kilocalorie this and 1 calorie is this. Then 1 electron volt is equal to 1.6 10 raised power minus 19 joule. This thing you need not to write another thing. You need not to write anything. Simply write these units, this and joule only. The SI unit of energy is joule. So this is the answer of question number 20. Now move to the next question, that is explain. Let me write here. Explain relation between work and energy with example. Now this is explain relation between work and energy with example. So simply you just start, right? Not in physics, you can write from here. This is question number 21 and it is at page number 44. Page 44 and this is question number 21. This is the answer of 2021. Work is said to be done when a force makes an object to move through some distance. Now, after this, you can simply write work is done. You can start from here. After writing that, work is done when force make an object to move through some distance in the direction of the force. Along with this relation you can write. After this, you can start from here and no need to write this. No need to write this. Simply write W is equal to F into S. This is force into displacement. First, from here, work is said to be done where a force make an object to move through some distance. Then work is done when a force make an object to move through some distance in the direction of the force. This, and then you can give the heading relation. You can start from here. Relation. We say that a person with more energy do more work than a person with less energy. Now you can give example of, you can simply write here the energy of the falling body may hit worker on his head in case he does not wear the helmet, or an object in motion has an energy equal to the work done on it. Start from here. We say that person, and you can leave this. You can start from here. Clear? First of all, once again students, write this up to here, then this, leave this right here, then write this thing, and then right here, an object in motion has an amount of energy equal to the work done. And then you can give example, this playing or running keep us fit, up to here. So this is the answer of question number 21. Now move to, this is page number 43, first one. Now the next is discuss different forms of energy with examples. Now students, what you have to do, you have to write the definition of all the types of energy, like, and you just give two examples only, like kinetic energy, this form of energy due to the motion of an object. After that you can give one example, A, B, any two example you can give. Definition, no need to write in between. Definition, two examples. Then move to potential energy, again definition and any two examples. So many examples are given, any two example you can write on your copy. Then move to electrical energy. Electrical energy, simple example you can give. Okay, so many examples are given, heater, washing machine, geyser, all that. You simply write this. Again thermal energy, definition and any two examples. Then light energy, definition, any two examples. Again sound energy, definition, any two examples. Only this much you have to write. Now, so it is given in the page, number 46, from page 46. You have to write all the types, their definition along with two examples. That's it. Now the next is, what is transformation of energy? Give examples. Today only we have done this. So you can write definition from the video, or you can write from here. So you just do one thing. You can start writing from here. You can give an example of bow and arrow. You can give an example of bow and arrow. You can give example. So that is enough for this question. This is question number 23. So this is the answer of 23. This is page number 51. Once again, students, in this question you just write the definition this, and you can give an example of bow and arrow. That's it. And it is given at the page number 51. Page number 51. It is given at the page number 51. Now state law of conservation energy with examples. Now it is given in the page number 53. It is given in the page number 53. You see, page number 53. What you have to do? You have to write the definition from here to here. Then you can give an example from here only. You can give example 10 joule of electrical energy. You can write this. This is the better proof for it. Okay, you can write this up to here only. So this is the 24. This is the answer of question number 24. Question number 24. This, or you can write. It's up to you. If you want to write this, you can write. Otherwise, you can give an example of this pendulum. It's up to you only, because you have to give examples. You can give any example. Now move to the next question. What do you know about the working of a roller coaster? Again, it is given at page number 44. Page number, this is page number 54, page number 54, question number 25. This is the answer of 25. Answer of 25. You can start from here. A roller coaster moves up and down and around a set track up to here. Up to here. Then you can give this flow chart. You can draw. No need to write this and that. You simply do this. So now the last question is, what do you know about the working of a hydropower plant? So again, it is at page number 54. Page number 54. Again, this is page number 54. Now this is the answer of question number 26. So simply you can start from here and up to the flow chart. Just write up to here. So with this, your this chapter is finished. So try to complete the work as early as possible, as your first term exams going to start from the next month. So even if you have any kind of doubt regarding any of the thing, you can send me the message, and definitely I will help you out for that. So that's all for today, students. Thank you very much.